Very good. So there you go. Just to reiterate, that's Starbucks Man and joshua.com. That's the awesome bird right there. This is me on the right. Thanks for joining me. I'm happy to be here. I work at Pivotal. At Pivotal, we have a lot of great open source software, not the least of which are the likes of things like RabbitMQ, Spring, Apache Tomcat. You know, we're major contributors to that, Cloud Foundry, etc. Projects are great insofar as they help our community and our customers and our community members and organizations around the world deliver better software. But what we really care about, the thing that drives us, our raison d'etre, is agility, right? We help organizations go quickly and safely to production. And that underscores everything that we do. We love production. We think about production all the time. And we know that organizations struggle with this. They struggle with how to get there faster. For a lot of these organizations, they've turned to this new architecture, microservices. Microservices help organizations go faster because they break the size of the batch of work. They reduce or decompose large applications into smaller, more easily digested, approachable, tested, developed, and deployed batches of work. And this gets you a lot of benefits. But when you move to this architecture, you invite complexity. You invite two new problems that you didn't really have to think about before. First of all, what is the cost? How quickly can you stand up a production-worthy service? If that cost is prohibitive, then you won't undertake the process of standing up a new service. And that's critical to being successful with microservices. If you don't have enough, if your services aren't working as you expect to in a microservices world, create more of them, right? That's the whole point, is lots of small, singly focused, manageable services, something upon which a small group of people can focus and iterate. So you have to be able to quickly stand up a production-worthy service. And then the second pain, the second complexity is, now that you've done this, now that you've moved to a world where you have lots of small collaborating services deployed over the network across network partitions, you've invited the complexity of a distributed system. And if there's anything at all upon which I'm sure we can all agree, it's that building a distributed system is hard. So today, we're going to take a look at how to build a distributed system and how to address these concerns quickly using something called Spring Cloud. So we don't have a lot of time, so I'm going to have to go very quickly. We're going to build a simple service here. Whoops. Okay. Close that browser tab. I can tell that's going to be a problem. Okay. So we're going to build a simple service. I'm going to go to my second favorite place on the internet. This is start.spring.io. My first favorite place, of course, is production. I've just realized that we're going to have some complexity here because we just released a new version of Spring Cloud today. So who knows if everything was going to be okay. It'll be an adventure. Follow us. Heck, I'm not even sure if I have those downloads cached. So what I'm going to do is I'm going to build a very simple service called the reservation service. We won't spend too much time trying to dissect what it does. I just want to have an API with which we can interact and to do so quickly. So it'll be a web application. I'll take advantage of JPA. I'll use H2, the in-memory embedded SQL database. Because it's an in-memory embedded SQL database, it's going to lose all of its state after every restart. And so in this way, it's very similar to MongoDB. It just loses data all the time. Okay. I'm going to use the config server, the Spring Cloud config server for centralized configuration. I'll use Eureka for service registration and discovery. I'll use RabbitMQ for stream processing, Zipkin for distributed tracing, REST repository support, and I'll use, I think it'll do, Actuator. That's important as well. So we'll go ahead and use these modules. These are simple modules that I'm going to use to build an application here. We'll generate a new zip file, and I'll open up this zip file in my IDE. And it really doesn't matter which IDE you use, so long as you do. So, okay. Reservation service, pom.xml. We're going to use Spring Boot. I'm hoping some of you have used Spring Boot. If not, now's your chance. It's a pretty cool way to get going. I made the mistake of having an existing application up and running. Close that out. Goodbye. Here we go. So, simple Spring Boot application. We're going to start here. We'll write a simple entity, a type of reservation. It's going to be a JPA entity, and I'll signal as much by annotating this with @entity. It's going to have two fields, a primary key called ID and a field called reservation name. And the primary key will have an auto-incrementing surrogate sort of value that'll signal as much by using these annotations. And of course, it's a JPA entity, so I have a fair amount of boilerplate required to make it work. This is exclusively for JPA. And And then we need a toString method for ease of debugging. Great. And what I want to do is I want to save and iterate and work with instances of this type. So I'll create what's called a Spring Data repository. And a repository is just an object that handles the boring, tedious. If I had the dependency, it would handle the boring, tedious, and oh yeah, Spring Boot starter data GPA. Are we confused, IntelliJ? Do you need a hug? Extends APA repository. There we are. That seems to fix it. No? I wonder whatever the matter is. For
those people who don't know, Josh, this typically doesn't happen.
Yeah, it is 11 o'clock in the evening. I'm happy that I got this far so far, but JPA repository. We're going to try a little bit something fiendish here, 1.40, and we're going to go back to Brixton XR3 just for sanity. We'll say, there. Wonder what that was about. Okay, so for the balance of my talk, I'm going to revert everything to Brixton SR3 and 1.40. In fact, I bet this would work as 1.41, which would make my life easier as well. No. There's something there. 1.40 it is then. Okay, so this interface is automatically implemented for us. We don't have to implement it ourselves. We can even, it provides definitions for all manner of different kind of CRUD kind of stuff. So find all by a given sorting condition, find all given a collection of IDs, flush, save, paging, sorting, all that stuff. I can define custom finder methods. I can say collection of reservation, find by reservation name, string RN, etc. There we go. Now I'm going to create a little bit of data. I'll say some sample data. So I'm going to create an object in Spring Boot it's a type command line runner, and the command line runner is a callback interface. So when Spring Boot starts up, it's going to find all instances of this type, and then it's going to instead it's going to call the run method, passing in the public static void main arguments here, and I'll take advantage of that to create some simple records. My name is Josh. It's lovely to meet you. Very good. And of course, I'm joined by my buddies Oleg and Simon and Roberto and is Trisha around? I need Trisha.
No,
good.
Ivan is around.
Ivan. Oh, hi, Ivan. Forgot about that. Good. So that's 6. I think that'll do, as my memory's pretty spent for the day. So all I'm going to do is I'm going to write these records into a database so we have some sample records for later, and then I'll confirm everything has worked as expected by iterating over each record and then printing them out. And what we finally want to do is we want to make short work of standing up a REST API. So I'll say repository REST resource. And I'll expose this endpoint as well as an endpoint that'll be mapped to a REST finder method. And I'll annotate this so that it has a Spring Data REST parameter exposed. And then having done all that, I'll spin it up and we're off to the races. We'll see it go. Now what I have now is a very simple application with 6 records saved in the database, and we're going to have a REST API. It's going to be a Spring HotOS REST API, right? This Hypermedia here, this HotOS bit refers to something called HotOS, or it's a design pattern called HotOS. It stands for hypertext as the engine of application state, right? And this gives us the ability to easily interrogate our service and understand what it's doing. So now I can go to localhost 80//reservations. I have my data, and I have these links, and these links are the hypermedia, the aforementioned hypermedia. These links tell me where I can go given the current resource. I can see that for this resource, there's a deep link called Reservations 1. I understand that if I go to Reservations itself, I can go down here. There's links telling me where I can go for the search endpoint. If I do that, I can see there's a finder method called by name. So now what I want to do is I want to take this application and consume it from a client. But the first thing I want to do when I start to move to this distributed systems world is centralize my configuration, right? If you've ever used Spring Boot, then you know that it's easy to configure things by going to source main resources application.properties and then specifying any property you like, be it server.port or any of the stuff having to do with almost anything else, right? There's a property here for that. But I don't want to have to recompile my code just to observe that change each time. So instead, what I'm going to do is I'm going to put my configuration in a central server. And that server will solve a few problems for me. It'll solve the problem of centralizing my configuration. Because it's going to be an API, I can also support symmetric encryption and decryption. Because it's centralized as well, I also have, and it's because it's based on Git or Subversion, I also solve the question of auditing and journaling, right? I can see who's changed the configuration and where and when. If necessary, I can also roll back. So let's build a config server here, choosing as we go 1.40. Or just 1.40, 1.38, 1.4. Okay, so we're going to build a config server, and this config server is going to manage a directory full of configuration powered by Git repository, based on a Git repository. So we'll clone that configuration here. It's online. You can grab it for your own edification later. It's on Josh Long, Beautiful Microservices config, and I'll just clone this directory to my desktop under the config folder. There we are. Okay. Oh, the config server, in order for it to do its work, it needs to be told that it's going to act as a config server. So we'll say @enable config server. I'm going to go back to the properties here, and I have to do a few things. I want to say that this one will be, I want this service to run on port 8888. And I want my config server to know where to find the configuration, naturally. So I'll say string cloud config server get URI, and I'll point it to my home directory /desktop /config, and we're off. Now, we start this, whoops. First time being home in a long time, so the keyboard commands on my proper Microsoft ergonomic keyboard are a little alien compared to those on my laptop keyboard. Okay, so that's up and running now. Localhost 888888, okay? And suppose I am a microservice called the reservation-service. What configuration would I see, right? I can answer this question by visiting the config server and visiting reservation service default, and I can see here I've got several keys and values for any microservice that identifies itself as the reservation service. Those configuration values live in the reservation service properties file, and then I have keys and values for all microservices, no matter what their identification. That's these two sets of configuration are sort of a cascade, right? The client, the ultimate client that connects as the reservation service, will see both these service-specific values and these values that are applied to all services. So I can configure the system as well as individual nodes. So with that in mind, let's go back to our reservation service, and let's change it just a wee bit, just to allow it to talk to the config server to draw its configuration. I can do this by having the Spring Cloud Starter config client on the class path. In order for that client to work, I need a few things. I need to give this microservice a name. So I'll give it a spring.application.name, reservation-service, and I'll tell it where to find the config server. So the config server in this case is running on port 8888. Okay, that done, I can take advantage of some of this configuration. I should see, if everything goes to plan, that it'll start on port 8000, and I'll inject or take advantage of this custom message here. So we'll say REST controller, whoops, class message REST controller, private final string value. I'll create a constructor. I'll inject this value into the constructor here. So @value, and I'll say message. And I'm going to stand up an endpoint here, public string read, turn this dot value. And here we are. Okay, now this will work, of course, but I may want to change this message later on. I may want to change this configuration value without having to restart the process. So in order to enable that, I'm going to make this endpoint refreshable. I'll say refresh scope, and then I'll restart. So right now we should see the default value with the one we've so configured earlier. That's hello world. And while I think this is certainly good enough, it's not great, right? We can do better. So let's confirm everything's working. It should be on port 8000 now, first of all. Value, rather. There it is. There's our custom message. The reservations themselves are still available as we expect. So value and everything else is working. Now, let's change this message. Let's go back to the config directory here on the desktop. And I'm going to open up the property file containing the message. I'll say, hello, Vija24, extra exclamation marks. So it's to reinforce my credentials, authority, and validity on Reddit. And then I'll commit the updated change. So I'll say git commit -a -m YOLO. And if I visit the config server, it immediately sees a new value, but our microservice does not. And this is by design. The last thing we want is for our config client to constantly pull the downstream config server. What I'm going to do is I'm going to force the microservice to redraw its configuration, to refresh its configuration by triggering a Spring Boot actuator endpoint. Actuator is a set of observable endpoints that are used to inspect or interrogate the state of a given node and to trigger operational changes. So in this case, I'm going to send an empty HTTP post to the refresh endpoint on the reservation service. And as soon as I do, I'm going to move my small arthritic fingers as fast as I can across the keyboard to then go to the browser and then hit Command R and see the change reflected in the output. So here we go, 1, 2, 3. Okay, very good. So now we can see the new value immediately, right? I've now managed to change the configuration without restarting the service. There are other ways to do this, of course. I could connect my microservices to an event bus, for example, powered by Apache Kafka or Redis or RabbitMQ, and then publish one message, and all so connected microservices would immediately update their configuration as well. This is based on, there's a module in that in Spring Cloud as well called the Spring Cloud Bus. So that's another option. Now, the config server is, as at the moment, it's unsecured. You can naturally lock down every aspect of it, but for now, it's fine. The next thing we're going to do is we have to care about how do services find each other in a distributed system. Services will come and go, and we would need to make it easy for these things to find each other as the topology changes in a cloud environment. So what I'm going to do is I'm going to use a service registry, and I'll point the service registry to my config server. And Spring Cloud doesn't really care, which service registry you use. We have adapters or integrations via the Spring Cloud Discovery Client mechanism for Apache Zookeeper, for Console, for Netflix Eureka. There's a non-GA version for etcd. You can use Cloud Foundry itself. I mean, there's a lot of good options here, right? But we're going to use Eureka, and there's a few reasons. First of all, it's very simple to set up, and so that's a big win for me. And second of all, it's been used at scale by one of the largest websites on the planet, so we know it works. We know it does a good job. I'll say @enable Eureka server. Spin this up, and take some tea since I'm getting a sore throat these days. Okay, localhost 8761. That's where, by convention, people tend to put their Eureka, and in this case, I've also got that in the config server. A couple things to notice. First of all, very good mouse over. I'm proud of that. I'm proud that we have people that do that. Second of all, no instances of the service yet. Nothing there. So we need to go back to our reservation service and activate the support for working with the Discovery Client, right? And we can do that by way of the Spring Cloud Starter Eureka dependency. So we'll say Spring Cloud Starter Eureka, okay? I think I've already got it in the class path somewhere. Maybe I didn't need to do that. So we'll just leave it out. Yeah, there it is. I'll just leave it out, and I'll toggle or activate Spring Cloud's Discovery Client, and I'll just restart my code, restart my application. That'll spin up, and it's going to register itself here and make itself available for discovery for by other services. And we're going to build a client, a special kind of client called a edge service. So remember, in today's world, lots of different services have different kinds of clients, and these clients are myriad. They are of all different forms and function and factors, and so we need to be able to accommodate these clients. But rather than retrofit every single microservice to which we want to connect to be able to accommodate these new clients, centralize these client-specific concerns in an edge service. You can handle things like protocol, payload requirements, translations of protocols and payloads, security, authentication, and authorization, for example. You can do rate limiting. You can do all sorts of interesting things here. So we're going to build an edge service using Zool, the micro proxy. We're going to also use a Hystrix, a circuit breaker, and Zipkin for distributed tracing, an actuator, of course, naturally, and RabbitMQ for stream processing. Oops, that was a good one, but not the one I wanted. Here we are, very good. So we'll build this up, and I'll open this up. In the meantime, let's confirm that our service is now available in Eureka. Since it's restarted, there it is. There's our one service. We have one instance, although if we started up 10, we'd see 10 here. The service is available on this IP, the service ID, and this port. Very good. Now, we are back in the reservation client, and I'm going to do the same things as we've done before. I'm going to say that this service is named reservation-client, and I'll say spring cloud.config.uri http localhost 8888, and I'll open up the code here. Okay, so I'm going to take advantage of service registration and discovery as before. So add enable discovery client. Now the first thing that we want to do is to make it easy for clients to talk to our downstream services. A common example of this is an HTML5 browser device, right? HTML5 browsers today and JavaScript along with it are very, very, very powerful. They can do all manner of interesting things. So we want them to be able to talk to our different services. For all of the power that your average HTML5 browser has today, however, they have one fairly significant but not game-changing limitation. They are sandboxed. They live in a secure sandbox, and that makes it hard for them to call services outside of the same origin. Naturally, I could visit every single one of my microservices and add the appropriate CORS headers, right? Spring MVC has great annotations that make it dead simple to declaratively configure the CORS annotations for a Spring MVC application. But this would mean retrofitting every single microservice, which would get me back in the same situation as I started. I don't want to change all the microservices just to accommodate my HTML5 client. So instead, I'm going to proxy the requests through a node, in this case, an edge service on port 9999, like this. I'm going to do so using something called Zool. Zool is a micro proxy from Netflix. This is Zool. For those of you who have seen the new Ghostbusters movie, you may not remember the very first one. Zool is the gatekeeper to the underworld. So we're going to use Zool, the proxy from Netflix, based on this amazing movie. Okay. So let's see it work. Localhost 9999, and now I can go to the route as a context path and then make a request to the downstream service. It says localhost 9999 service ID as we registered it in Eureka here. Service ID is the same as it is here, and then this is the actual path as we would have sent it to the actual service. We get the results as we expect. A couple things you may be wondering. First of all, how are these URLs correct? Right, the URLs as emitted from this edge service are exactly as they would have been if they were emitted on port 8000, except that they're from the correct host and port. So localhost 8000 reservations, localhost 9999 reservation service reservations. The proxy sends requests x-forwarded -port, x-forwarded -host, etc., etc., etc. And these values are used by the downstream service to write their URL. So the HTML5 browser client has no idea, from its perspective, this JSON was generated on port 9999. The other thing is, how did it know to which instance it should route the request? And it knew this because it used the service ID to interrogate the service registry via this discovery client abstraction, and then it passed all the discovered service instances. It got back all the collections of all the service instances in a collection, and it passed those to a component called Netflix Ribbon, which is a client-side load balancer. The client-side load balancer makes it dead simple to programmatically handle load balancing discussions and decisions on the client. So instead of just doing the common case round robin, for example, you can do much more interesting semantic kinds of load balancing. You can say, I want to do data sharding or data locality or multi-tenancy. I want to do data center aware load balancing, or I want to do something that your average load balancer just wouldn't do. For example, suppose I'm a client and I have an OAuth token, and I want to route the client with that OAuth token representing, for example, Oleg or Simon. I want to route that particular user to a long running process on a long running stateful process for that user on a particular node. Most load balancers will have a notion of stickiness, but they don't know about OAuth. They don't know about your particular business process, right? So now you can make that decision here. You can say, this request is coming in from from Oleg or from Simon or whatever, and I want to send the request to the node that's actually handling the workload for that user. So now I've got a very simple edge service. It's a proxy, right? I'm proxying all the requests. And if I have a homogeneous set of HTTP-based services, this is fine, right? Sometimes, however, I want to be able to transform or translate the downstream data, get a different view, right? So let's build an API gateway. We're going to add an endpoint here that'll just transform the downstream services, the downstream rather reservations here, from the full JSON strata, right, to just the names. And so I'm going to take the Spring HardOS payload here. This is this blue JSON, this selected box here represents a Hypermedia resource envelope object. The resource has a payload, that's this, and a collection of metadata links, that's these, right? I want to turn this JSON back into a resource and then unpack the reservation payload and then unpack the reservation name and keep only the names themselves. So ideally, we'll have a new endpoint that just returns all of the names for all the users. Okay, so we'll say reservation API gateway REST controller. Okay, and we're going to build an endpoint here. We're going to say public collection of string names, and we'll return HTTP GET, and we're going to return a collection of names. I'm going to map this endpoint to /reservation. So this will be reservations on port 9999 / names. And when somebody makes a request, we're going to use the Spring Framework REST template. That's a client that is used for calling REST endpoints. I'm going to use the REST template, but my REST template doesn't know about our service registration discovery. It doesn't know about ribbon. So I need to configure it to be a little bit more aware, to be a little bit more intelligent when it works with services that could be load balanced by configuring an interceptor on that REST template using this qualifier annotation that'll signal to Spring or the dependency injection container that this particular instance is to be configured with an interceptor. So now I'm going to say this.rest template.exchange HTTP / reservation -service. Now that's not DNS, friend. That's a service ID that we've passed into the string that's going to be extracted whenever this method gets invoked, and then sent to the registry to retrieve the server instances, whose results will be then sent to Ribbon, which will then be used for client-side load balancing. And finally, when we have a resolved service instance, we'll use the resolved service instance to substitute that string in the URL. And then finally, for the last parameter, we need to tell Spring what kind of data we want back. So I'm going to use something called the type token pattern here, right? I'm going to tell Spring that I want a collection of resources whose payload is of type reservation, right? And I'm forced to subclass this, right? This is an object that I can interrogate. I can ask for its generic parameter, but in order to make this work, I have to subclass it. But you'll notice that this doesn't quite work, does it? I don't have this type. I could, of course, copy the type from the service implementation to the class path of my client. But again, I want to keep some autonomy here, right? The whole name of the game with microservices is to have the ability to go fast and control your own destiny. So if I'm beholden to another team's schedule to update my clients and so on, then I lose some of that freedom. So instead, I like to use a client-side representation, a DTO. And if you're using schema-based payloads, using, for example, Google protocol buffers, this becomes very, very simple to manage, right? The clients and the producer and the consumer agree upon the schema, not a particular object, right? But in our case, it'll be fine. So I want to pass that in here. And now I'm given a response entity that has a collection of resources whose payloads are of type reservation. And I'll say response entity.get body. That's what I want. I don't want the status code. I don't want the status code value. I don't want the headers. I want the body. So that's this. I'll unpack the particular payloads, the reservations, and I'll map over them, right? I'll map, and I'll say for each R, let's get the reservation name, and then I'll collect all that into a list. Now, of course, this could be a method reference, so let's take advantage of that and restart, okay? Now, this code, it works, but I would argue it's a fair bit tedious, right? If I'm building a system, the last thing I want to do is to have to rewrite the client code for this service every time. I'll quickly end up, this is not so bad. It's only 2 or 3 fairly gnarly lines, but it's still littered throughout my code base, and I have to reinvent this every time I call this service. One solution to this is to have the teams that build the service also build a client API, but this runs the risk of having too much magic in the client binding. So Amazon, for example, says if you're building a service, you cannot build the client. Other teams should build it. That way, it's clean room. It's guaranteed to be a useful service all by itself, and you don't need a particular language binding to be able to use it effectively. That's a very, very powerful approach, but other organizations are a little more pragmatic. Netflix says they're also leery of having too much magic based into the client, but they don't worry too much if the client is declarative, right? So I'm going to use Spring Cloud Feign here. Feign is a project from Netflix, which allows me to declaratively, based on interfaces, create a client for a service. And this makes it much simpler cognitively. The overhead of understanding of what's happening here is much reduced. And of course, I get a correct REST API client, right? So come on. Okay, value equals reservations. Okay. Request method. Very good. So there we are. I can now enable this. I'll say @enable Feign clients. And I'll rewrite this code, simplify it a fair bit, okay? Before I do that, though, let's make sure it works. So localhost 9999, reservations names. Voila, there's our endpoint as it's written. Let's refactor a little bit. And I'll inject here, I'll say private final, reservation reader, or reader. And I'll inject this here in the constructor instead. And I can now remove the REST template. I don't need that anymore. This goes away, becomes irrelevant. And then I can replace this code as well. I can say reader dot read and get rid of that. So now we have the same functional API, but it's much cleaner. Now, let's in this case, if I make a request and there's a downstream service, great, it's going to work. But what happens if there are no downstream services? It's going to throw an exception, and that's not good because I want this to be a little bit more robust, and we need to understand that in a sufficiently distributed system, failure will happen. So I'm going to use a circuit breaker to make sure that if something fails, I have a degraded sort of response, right? So I'm going to use a circuit breaker here, and I'll add a fallback method. I'll say public collection of string fallback. I'll return a new array list, just an empty array list. A lot of high-performing websites will do this very sort of thing. They'll say, oh, well, you went to the search engine, but the search engine isn't working, so here are some machine-learned recommendations from across the web. This is very important because it protects our clients from failures in downstream services. Now, right now, everything's fine, right? This is the happy path when it restarts. We'll see it'll work. But we don't want to, come on. Are we up to good? We don't want to assume that the best will always happen. That's a very immature approach to building distributed systems. So right now everything's fine. The happy path is working. If I now go to what is this? Oh, I've got Zipkin. I've got the Zipkin client on the class path, my friends. So it's upset that we don't have that Zipkin service running right now. We'll remedy that in just a moment. So let's go kill now the reservation service here. And as soon as I do, I refresh, and now I get the empty array list. I don't get an exception. It timed out. You can't see it. It's ever so brief, but it makes the request and then times out, then an exception is thrown, and then the circuit breaker kicks in. If I make enough requests, if I lay down on the request, the refresh button here in the browser, eventually it no longer times out. The request goes directly to the fallback. The circuit breaker is stateful. It actually sees that enough successive attempts to call the service have failed, and so it just directs traffic directly to the fallback. It protects the downstream service. The last thing that we want to do is, if a service is trying to recover, is to deluge it with traffic that it's not prepared to handle, right? So this is a way to protect that downstream service. Now, it's also going to reintroduce traffic as it becomes possible, right? So that's very, very useful as well. What I've ignored for the purposes of fitting in our brief allotment of time today is the question of how do I handle a write? Right now, I've just read data from a downstream service. If I wanted to write data to that downstream service, I couldn't really use a circuit breaker. I would need to use an alternative approach, something like eventual consistency. And for this, I encourage you to take a brief look at Spring Cloud Stream, which makes it dead simple to build event-based, messaging-based microservices using, for example, Apache Kafka, RabbitMQ, Redis, etc., and using declarative-based communication between these services. In this case, you can have an edge service that takes a post, and you could write the value to the broker and then deliver that result to the downstream service if the downstream service is available. And if it's not, you could, buffer it in the broker, right? Thus ensuring that the write eventually agrees with your worldview. It's eventually consistent with our understanding of the worldview. Okay, so we've thus far looked ever so briefly at how to build a robust, resilient service. It takes advantage of the scale of a cloud. It does the right thing if services should fail or if the topology should change. But let's talk about observability, because this is another tenet of a cloud-native system. We must understand that the map is not the terrain. In the streets of San Francisco, that's not the same experience at all as looking at the map. The map is an approximation. It does not even begin to capture the nuances, the smells, the sounds, the traffic, the hustle and bustle of being in the city, right? Of being in any particular city. And the same is true of your production system. There's emergent behavior in your production system that you cannot hope to capture by looking at the architecture diagram. You need to understand what that system is doing. So one way I can imagine capturing this information is to monitor that circuit breaker. That circuit breaker represents sort of a proxy for a downstream service. In this case, it's a service of our own design. We have control over the service, but we don't always have that ability. We don't always have the ability to change other people's services, right? So the circuit breaker represents a proxy. It's sort of our way of being able to monitor and make more robust other people's APIs. I cannot change other people's APIs. I cannot add Spring Cloud to their code base. I cannot use Cloud Foundry to make it more robust and scalable as in a cloud system. But I cannot insert my agents, my monitoring agents, into their infrastructure. But I can monitor the connection from my client code to their services via that circuit breaker. Right? That circuit breaker serves as a bit of a proxy, if you will, for their infrastructure. So we'll say, let's build a Hystrix dashboard, and we'll spin this up. Okay. And this circuit breaker dashboard is going to expect a circuit breaker stream that our microservice will emit on port 9999 Hystrix.stream. Now, the stream is infinite, right? So it goes on and on and on and on and on. And it goes on forever. It's endless. It has no end. It is without end, right? It continues ad infinitum, forever, with no stop, like the oceans, like the skies and the stars and the bugs in my code, just infinite, just forever. So whatever you do, my friends, whatever you do not curl this endpoint. Now what we're going to do is we're going to visit the Hystrix dashboard here, 8010, hystrix.html. We're going to paste that URL in there, and I'm going to hit monitor. And now, as I drive traffic here on my endpoint, I can see the moving average reflected here on the right. I can see that I've made 23 requests, 29, 34, et cetera, et cetera, et cetera. And that moving average is trending ever upwards. If I were to go down to my reservation service, again, and kill the poor thing again, we'll see that the circuit will stutter, it'll hesitate, it's trying to call the service, it's failing, 13%, 28%, 72% errors, all the requests are failing, and now the circuit breaker is open. It's routing traffic directly to the fallback. So this is one way to get visibility of the flow of data between systems. Another way to get that visibility is to use distributed tracing. And in theory, distributed tracing is very simple. All you need to do is to capture for every request that's sent into the system via the Zool microproxy or via a Spring MVC REST endpoint or via Ratpack or via the Spring Cloud Stream Kafka messages being delivered, for example, or any message that leaves the system, any message that leaves via the REST template or Spring Spring Cloud Stream and Kafka or RabbitMQ or Redis or whatever, or the Feign declarative-based REST client, any of these ingress and egress points in the system, I need to affix a unique ID, a correlation ID, an identifier that I can use to trace the transit of that message through the system. And I have Spring Cloud Sleuth, right? Sleuth. Sleuth, of course, is sort of like a detective, right? So Sherlock Holmes. We have Spring Cloud Sleuth. Spring Cloud Sleuth is the discovery client abstraction. Sorry, it's the distributed tracing abstraction for Spring Cloud. And we can see it's already in play here. You can see the service ID, the trace ID, and the span ID. The trace ID is a unique identifier that represents the aggregate journey of a message through the system from A to Z, or Z if you're in the States. It's one unique ID for the entire journey of that message. From if it's one service or 10 services, you get one trace ID, same one. The span ID is different for each leg in the journey, for each hop, for each request. So from A to B, from B to C, from C to D, etc. Now this is already pretty useful. If you have Elasticsearch or Papertrail or Splunk or something like this, you can drain these logs and then analyze them by kind of sifting through the logs. But this is not nearly enough. I'm a big believer that a picture is worth 1,000 spam. So I'm going to go ahead and stand up a Zipkin service here. Zipkin server, Zipkin UI, config client, and Eureka discovery. And now Zipkin is an open source distributed tracing platform from Twitter. We are fortunate enough to have on the Spring Cloud team contributors and developers from both Twitter and Netflix who help make Spring Cloud awesome. So let's go ahead and let the download continue when the time is most critical. Okay, Spring application name, Zipkin -service, Spring Cloud config.uri equals HTTP localhost 8888. And we'll open up Zipkin service application. And I'll say @enable Zipkin server @enable discovery client. And we'll go. I'll take some tea. Now, localhost 9411. Okay, there's our Zipkin distributed tracing server. It's a simple instance. Right now we have no persistence, but that's easy enough to remedy for your own. It's an exercise for your own pursuit later. Let's try it out. Let's go to our reservations names endpoint here. Make a few requests, and then visit the Zipkin service. We can see that it's aware of the client and the service. If I go to the service, I can see that there are these different endpoints. I'm going to hit find trace, and I can see that less than a minute ago, I made a request that went through the system. You know, these requests were of various lengths. I can go to this one, for example, 18 milliseconds. And I can see that the request started on the reservation client, and it went to the reservation names endpoint. Still in the reservation client, it went to the names method. Excuse me. And then still in the reservation client, it left going to some endpoint called reservations, which is HTTP-based, which is, as we see, on the reservation service. So the message left one node and went to another. And we can see the flow, the relative timings of that message. I can click on any particular span. That's what these blue bars are. And I get a sort of a detailed view of the nature of that request. I can see the request log. I can see these custom tags. These tags tell me about the nature of the request. In this case, it's an HTTP request, for example. I also get this pretty graph. I'm a big stickler for graphs, so there's that. I can see the directionality of the requests and the usage of the services and so on. So I get a lot of functionality. I can now understand what the system is doing right now, both with the Histrix dashboard and this. This is all about online telemetry. It's all about right now. You're not going to use this information to find out what Josh did on the website 5 years ago. Most organizations keep at most maybe a few days, maybe a week's worth of information. You're going to only keep a small subset of the data too. You're not going to keep it all, right? After all, I don't need all of it to understand the patterns. I'll keep maybe a tenth, which is what Spring Cloud Sleuth keeps by default. So my friends, today we've looked ever so briefly at a few things that you can use to build a distributed system that is robust and is resilient. It takes advantage of the elasticity of a cloud. It does the right thing in the face of service outages and topology changes. It's easy to develop. That is to say, it's agile. And it's observable, right? We've looked at observability and everything else in terms of Spring Boot and Spring Cloud. Now, I hope you liked what we talked about. Certainly, I'm a big fan. If you didn't see me earlier, I'm wearing a Spring t-shirt, and it's 11 o'clock at night. Of course, I'm a fan, but you don't have to take my word for it, right? There are organizations all around the world that are using this loudly and proudly, and they've talked about it before. So, for example, Netflix here in the West is using Spring Cloud, not just the constituent components, but they're using Spring Cloud itself, because for them, this is the most productive and comprehensive way to get to production. In the East, in China, Alibaba is an e-commerce engine, and they're using Spring Cloud at extraordinary scale, right? Forget about web scale, China scale. Here in the West, we've got Ticketmaster. They're also using it for their service platform. $100 million of commerce every hour goes through services powered by Spring Cloud. In the East, Rakuten.com in Japan is also using Spring Cloud. Again, another e-commerce giant in the Far East. So lots of different use cases, right? But this is also being used by banks and financial services companies and insurance companies all around the world, right? That is, after all, Pivotal's bread and butter, is these organizations that want to go faster, and they've traditionally struggled with it. So for them, as well as these web giants, these technologies represent the best way to production. And of course, these are not to be used in isolation. You shouldn't move to microservices if you don't have the ability to get continuous feedback through, for example, test-driven development and continuous integration, and if you don't have the ability to automate non-functional parts of the pipeline, the value chain, like deployment to a cloud. This is why I wholeheartedly recommend you look at things like Cloud Foundry, which is an open source platform that's optimized for continuously delivering software to production. I want to thank you so much for your time, my friends. Don't hesitate to reach me on the internet, as I say, at Twitter at StarbucksMan, and by email, josh@joshlang.com. Hey, Oleg and Simon, boys, you did a great job. Thanks so much for having me this time. I know you were on the line about whether I should be allowed to join, and I think you made the wrong decision in letting me stay, but I'm very grateful you did anyway. Thank you so much.
It was really amazing. Thank you for coming here, and thank you for being with us. We are suddenly